Hello students, now in this video I'm going to start the new chapter, that is chapter 3. Okay, type of software. In this chapter we will get to know about how many type of software is there and from where it has been started. Okay, so let's start the topic from something is already written on the board. We will cover these points today. This is all information we are going to get. Okay, first of all we are going to begin from the system software. When the hardware was there, means hardware can't execute or cannot run alone. We need a software which help the hardware to, or which collide the hardware, contribute the hardware to work together, and then complete system when both coordination between the hardware and software combined together, then proper computer used to be working. Okay, so system here in the system software, first of all those software which helps the system basic communication between the computer and the hardware. Those software is called as a necessities of the computer, and we call it those one as a system software. Is very much necessary for the computer. Okay, in the system software, two types of software are there. Basically two types of software are there. Means without these software, the system is quite difficult to run. The computer doesn't perform any work, any task. Okay, so first of all, translator. Okay, translator, when you are translator software, hence it has been not given in the book, but three software is given already, that is assembler, okay, which comes under the translating software. Okay, what translating? Your program, your information, your code into the computer language. You know that computer language or machine language, machine used to understand the language of 0 and 1. Okay, 2 bits are there, on and off bits. According to that bunch of bits together make some sense to the computer, gives the information to the hardware, and then they execute it under the processor. Okay, so first of all I have told you in the translator, it comes in the beginning assembler. As time to time moved on, from the assembler translator, it has been improvised from assembler compiler. Okay, compiler, and then after compiler, the translator, which comes just after the compiler, next version, interpreter. We are going to study these all things only today, and since these all software are to convert your program, your code, your programming code into the machine code. Okay, machine languages. Okay, so in the machine language, your language into the machine language, your programming language into the machine language, these are responsible. But all are those, I'm not saying that all are working together in your computer. It depends on the program, on the language which you are using. Means from beginning, earlier time till now, it has been developed like in this series. It has been developed in this sequence. Okay, from assembler, then after compiler came, and then after interpreter came. So what are the languages which are in this, and what are the difference between them? So I'm just deleting this operating system so that I will be able to write something on the board. So operating system is also a system software, which is the interface between the user and the other application software on which you are using. This topic I'll cover later on. First understand what is an assembler. Okay, assembler. assembling software. Assembler is a software in which when the it was a time of beginning of the computer, when the computer was just made and the programming was going on in the computer. Everybody was just knowing about the computer. It was very big word for any big thing to purchase a computer. That time means 15 year or 20 year 25 year back, when the computer was there in the market. That time the program which was created, the software which was written in the language, that was called as a assembly language or low level language. You might be knowing about the two different languages in which the program was creating a programming language has been divided into the two different languages, low level languages and high level languages. In low level languages, assembly language is also called a low level language, or in the pseudo code, means that let me write here, or assembly language. We can also write it assembly language or low level language. It means that in which the code which was created to instruct the computer or to instruct the assembler to the machine, which was later on converted into the this was input, this was given to the processor to assemble, just to convert it into the machine code. That is 0 and 1, means this was converted into the machine code. But this language, generally we basically know that we used to write a program in English language. All the computers are accepting the language of program in English only. But somehow nowadays the language which we are using to write a program, that is common and sensible pattern. The syntax of the program or the code of the program is somehow we can understand. It's simple English language only in proper. But that time it was written in the code, and that code was known as a fake code. Pseudo code means fake. The assembly language or low level language, we can say it as a pseudo code. Means pseudo code means you have created some code, some instruction, some command which is unsensible. But for me it is a code, and for the listener, for a receiver, it may be a same sense that I have created it. Means other person, other user cannot understand what it is. Like I have told somebody tick tock, this is a code for me, but it doesn't mean anything. So I told someone that tick tock means to walk over. Tick tock means to walk over. So I know that I have created this code. This is a fake code, and he is knowing that TikTok means walk over, but other person will not come to know. They will be just wondering what it is. Like that only, the code was not actually English according to the English language, but it was written in the English word which was totally fake and unsensible. That was understood by the computer when it was converted into the machine code, means 0 1 0, string of 0 1 1 like this, and then it was sensible when it was converted into the machine code, and then it was totally executed, and that program was understood by the computer machine, and then it can be used. Means it was quite difficult to understand other programmer to which kind of language. That's why it was called as a low level language, only understood by that programmer who has created, or by the machine who is converting, by the assembler who is converting those pseudocode into the machine code, and then after machine can understand what it is. Okay, what does it mean? So in assembly language, the question can be asked that in assembly language, which language to which code it used to be converted. So in the beginning of the translator software, it has been started from the assembly language. The translator software has been started from the assembly language only, and then after later on it has moved to the assembly to the compiler, so that in this high level language was used. So in low level language was converted when the programmer used to create any code, any program. It was written in the low level or assembly language. We can also say low level language is called as a assembly language, and then after it undergoes with the assembler, which converts it into the machine code, and it was understood by the machine and executed properly, so that your program can be run over the computer. So assembly language, you understood, it was a short and perfect explanation in this assembly, not very much detail in this, because it was for the short period of time. It creates so many problems while developing a program. But next, when compiler came, high level language was converted into the machine code. In this, we have to keep in mind that source and object, it used to, one point is there, source file and file. Source file are those program which is all the high level, when it is written, the program is written with the multi-line instruction, that is called a source file. After compiling it, after converting it into the machine code, that is called, after executions, that is called object file. Okay, source file which hasn't undergone into the compiling position, means still it is a program and it has to be compiled, and then only after error free, means if it will be error free and ready to compile and ready to execute to give the result, after that final executions, it will become a object file if the program is perfect. Okay, so source file and object file you should be remembering, or it is written in the book also, definition, what is a source file and what is an object file. Means after compilations you will get an object file, and before compiling any program, it will be a source file. Okay, what a compiler, as I was telling you, compiler used to translate high level language to the machine code. Okay, machine language, and assembler used to translate a low level language to the machine language. Okay, and high level language, this also include the high level language, this also include the high level language, but both high level language programming language is different, which has been categorized into the compiler high level language, which and another different programming language is categorized into the interpreter high level language. But it cannot be possible that a programming language which has both compiler and interpreter, you will not see this kind of mixing. So in this high level language, you will get the programming language such as C language, C++ language, okay, Pascal language, COBOL language. When you might be studying about the generation of computer, in the earlier class, 8th class, the different languages were there which you have already come across. Okay, so these are the language which comes under the high level language, and they are the translator which is used inside this. That translator is compiler. Okay, so and many more, not only this, many more languages are there which is used in the high level language of compiler. And then after, it used to be when the program used to written in this language, then compiler is there to convert it into the machine code, that is string of binary code. Okay, a point is also given in your book, goes through the entire program. In this one thing is there, when you write an entire program with a multi-line, and this is a total program with the instruction, multiple command is there together with bunch of command. When both all will compile together, if there will be no error, means thus in the compiler reads whole program together, and at last they used to indicate the error. While programming languages is having some syntax error or any line error, they will show it at the last. So the point is there, it goes through entire program and check grammar of languages. Means some in text writing, some language grammatically mistake, not your English grammar. Means programming language grammatically mistake might be there, might be left, might be misspell. So that kind of error will show after compiling whole program, and at the last with the indication of line, that particular line, in which line you have committed a mistake, that will be shown as an error, and you can improvise it. Means in this what we have studied, in compiler used to read whole program, and after last program, entire program, after reading entire program, at last they will tell you what is the mistake. Means in between they are not going to tell you that your mistake is in the second line or first line. If there will be a mistake also, then at last only you will come to know after compiling then where is the mistake by their indications. Okay, if error, then report with the number of line, in which line, number of line there is a mistake, it will be indicated to you, to the user. Okay, so now this was the information of the compiler. But in the interpreter what happens, that is also having the high level language. Interpreter, machine code, all used to convert into the machine code, because machine has to execute, and finally the process means output will be given from the machine processor only. So all information should be understood by that computer machine. So that language is different. So it is the responsible software who converts your language, your programming language, to the known to language of the machine, and then machine will work over it, and it will give you the output. Similarly, here I was telling you, in the compiler, high level language, in here also high level language, but which program is there? In this, basic program is there, Python, Java, etc, etc, etc. So many are there. C#, and many more are there. So in this many languages are there, programming language, in this high level language, and it used to be they are having the translator, name, interpreter. These languages are having the translator, name, interpreter. Okay, and this interpreter used to convert this language into the machine code. And in this, how it used to be interpreted, means if you are writing a program with a multi-line instruction, so line by line this used to interpret. Means first line will be read, if there is no error, it will the interpreter will move to the next line also. If there is no error, then it will move to the next line, and if it is the error, then it will not move to the next line. You have to correct in here only. Means when you are interpreting line by line, it will stop reading next line of the program, and it will stop there. You have to, until and unless you will not remove the error, you will not make it as an error free, it will not move on to the next one. Means line by line reading process is done by the interpreter. It takes a long time to complete the program. Okay, means finally you have to reach at the last, interpreter will reach at the last line, and when it will reach at the last line, you will come to know that before the last line all the program instruction, all the lines of the program is okay. Means now it is the final touch up to the program to execute. So that's in this you have seen the line by line, when it is interpreter is reading or executing, and fetching the program error free, it will take a long time to execute or complete the program or to run the program. And in this, at a time, whole program is compiled and saved. Okay, so here we can say it comparatively that interpreter is slower than the compiler. Interpreter is slower than the compiler. Hence, in the Python, you will come to know that some of the basic program in the further, when I will teach you in Python, some of the basic here I have written in the high level language in the interpreter, no, but some characteristics is there in the Python which is used by the compiler also, because Python is nowadays everywhere in each and every, most of the web designing and other software are using the programming language of Python. Easy to develop the software. Okay, except a mobile software. Only a mobile software cannot be developed by the Python code. If you will see or get in this class, you will just read about the overview of the Python in the last chapter. But I will tell you the importance of the Python and how it has been developed as the time will come. Okay, so this all information I have given you today. Error free. As I have told you, until and unless the error free line will not be there, the interpreter will not move on to the next line. But here compiler will compile all together, and lastly they will indicate you the error of the program. So this much was there in this topic. I have told you about the assembler, compiler and interpreter, and it is the family tree, under the family tree of the translator, which is not in the book, but understand translator software under which the assembler, compiler and interpreter used to come. And next topic will be operating system is a system software. This is a system software which is already very much necessary in the computer, because until and unless this translator software will not be there, nothing can execute, no performance will be there in the computer, because machine who is there, who will convert your instruction, your information, your program into the machine code. These are the responsible. That's why this is called as a system software. Means without system software, computer cannot run. Then after operating system, it's a bit very much lengthy, because in the operating system we are going to study about the type of OS. Okay, now let's see how many wide topic it is. Okay, function of OS 1, 2. Okay, need of OS. These all points you have to remember. I will explain you point by point, don't worry. But type of OS, function of OS, need of OS. Now come to here, type of OS based on user interface. Type of OS based on user interface, and type of OS based on functionality. Okay, functionality. Okay, any problem? So here type of OS based on functionality, different with the different function, different OS are there for the different function, but according to the user interface, OS also has been divided. Different OS is there, operating system is there according to the user interface. GUI and CUI, we will study about that. And here on the function means like an operating system, when we will study about the Windows and all. And 4 points are there four things you have to remember. Multiple points will be generated in this kind of category, okay, which comes under the topic of operating system. Okay, 4 points are only there. So I'll cover this into the next video because this video will be very much lengthy. Thank you very much, and you will get the second video of this chapter, type of software, soon. Thank you.